Hey guys, hope everybody's having an awesome day. So you guys just finished watching a video made by Mrs. Zimmerman on discovering the tangent and cotangent graph. So basically, where do they come from based off of this? Tangent of x equals sine of x over cos of x, using your guys' knowledge of the unit circle. So now in this video, what we're going to be doing the rest of today is actually graphing functions. So first, where does all the critical information come from? So first, Mrs. Zimmerman touched on this a bit in her video. Amplitude is in quotes there. That's because technically amplitude does not apply to tangent. The definition of amplitude, half the distance between max and the minimum, or the distance from the midline to the max or the midline to the minimum. There is no max and there is no min. As you see, tangent graphs go up forever, they go down forever. So technically there is no amplitude. So the concept of amplitude doesn't apply, but we still have it here and it's in quotes because that A value in front is still helpful. And you'll see when we start graphing, we still need to use that. Basically, it's going to help us plot these points. Okay, so the amplitude technically is not a thing. We still need that A value to help plot some points on our graph. Okay, period, super important. It is not the same as the other four. Period is pi over b. Okay, so hopefully you all should have immediately noticed it's pi over b, not 2 pi over b. And then the DCV is still period divided by 4. So DCV you find the same way as you do for the other four. All right, vertical asymptotes. So this is how you write them. Okay, and every time they're going to be a little bit different, but for the parent function, it's pi over 2 plus or minus pi times k. Okay, and that would be the specific correct answer for this parent function. Okay, but in general, it is the first asymptote plus or minus the period times k. Okay, and when we get into actual graphs, I think that will make more sense and we'll be able to explain what that means. But basically, you have multiple asymptotes. So the first one is at pi over 2. So if you want to look at this graph, that's right here. That's the first one. Plus or minus, meaning there's some asymptotes to the right, or plus, some to the left, minus. Okay, and then pi times k, the period times k. So for tangent and cotangent, the period is the distance between asymptotes. So if you go from one asymptote to the next, that's one period. So basically, it's like the starting point is pi over 2, or the first asymptote, and then right or left by pi, or the k means k can be any whole number, any multiple of pi. So like if you add 1 pi, you're at an asymptote. If you add 2 pi, you'd be at the next asymptote over, and you could do the same thing to the left. Okay, so that little expression, pi over 2 plus or minus pi times k, represents every single possible asymptote. All right, and then the last thing, the axis of the wave is the same. It's y equals d. Then I just want to add one more thing to these notes, positive versus negative. So a positive tangent looks like this, bottom left to top right. Negative is top left to bottom right. It is kind of a similar concept to slope. Tangent is exactly what you would think it is. When it's positive, we're going bottom left to top right, or left to right, you're going up. Negative, left to right, you're going down. All right, so that's all that happens if you add a negative in front. It just really changes the shape. All right, so pause right now and finish these notes if you haven't already. And in 1 second, I'm going to scroll down to page 3. Okay, so now page 3, the first thing at the very top of the page, this should say cotangent. My mistake. They're not both tangent. It should say cotan. Okay, so now for cotangent, what's the same? Amplitude, still A. Period, also pi over B. dCV, still period divided by 4, and the axis of the wave is y equals d. Okay, what's different for cotangent? With the asymptotes, it is 0 plus or minus pi k. All right, and again, it's going to be first asymptote plus or minus period times k. All right, so notice the pi times k is the same because for both parent functions, the period is pi. But what's different for cotangent is your first asymptote is here at 0, not at pi over 2. Okay, but the rest is the same, plus or minus, so there's some asymptotes to the right, some to the left. Pi is your period, so there's an asymptote every pi units. And that's kind of easier to see for cotangent. Since the first one's at 0, the next one's at pi, that's a distance of pi, which is your period. So you see the period is the distance from one asymptote to the next. All right, and then the other thing that's different about cotangent is it's the opposite. Okay, so when cotangent is positive, left to right, it's going down. Negative, left to right, it's going up. Okay, so in a way, positive cotangent graphs look like negative tangent, and negative cotangent look like positive tangent. All right, so pause now and finish taking these notes for cotangent if you haven't already. All right, so now I'm going to scroll up to number 1. We're going to go through an actual example and figure out how to graph these. Okay, so first thing, let's do the critical information. So amplitude, and again, it's in quotes because technically it's not an amplitude, but like the way that I would say it if we were in classes, I would say, what is A? Because it's not really technically an amplitude, but it is still A. A is 2, the leading coefficient. All right, the period, remember, it's not 2 pi anymore, it's pi over B. Here B is 1, so the period is just pi. And your dCV, you always take your period divided by 4. Vertical asymptotes, I'm actually going to do after we graph. Okay, but axis of the wave, is 0. It's just the number at the end. Really, there's like a plus 0 at the end here. All right, so now graphing this. First, you scale your x-axis by the dCV. Okay, I'm going to go every 2 here, so it's pi over 4. Next is 2 pi over 4, 3 pi over 4, etc. I'm going to pause now and fill in the rest of those labels, and you should do the same. All right, guys, so at this point, you should have the labels the same as mine. All right, and now we're ready to start graphing this. So first, graphing tangent, okay? At 0, your starting point, kind of like sine, is on the axis of the wave. It's on the midline. So I have a point here at 0, 0. Okay, that's the first thing. Now, to the right and to the left, you need to create 1 point each. So basically on each dCV. So at pi over 4, I should have a point, and at negative pi over 4. In each direction, from that midline, you have to go up or down by A. But the question is, to the right, do I go up or down? And to the left, do I go up or down? You need the shape, since this is positive tan, to look like this, left to right, going up, kind of like a positive slope. So therefore, and don't forget to label your y-axis as well. But therefore, since it has to be positive, to the right I go up, and the amplitude A is 2. So to the right, next dCV over, I got to go up 2. To the left, down 2. Okay, and the next thing is your next dCV to the right in both directions is an asymptote. Okay, so what we're creating here is like our first section of our graph. Okay, now connecting the dots here. I'm going to make my down arrow. It looks similar to a cubic curve. Okay, it doesn't need to be perfect. I'm certainly not an artist, but they shouldn't be straight lines. Okay, and now you should approach your asymptote but not touch it in both directions. All right, so now the starting point was at the midline, right? The other thing you can do right off the bat, the first asymptote will be 2 dCVs away. Okay, so again, from the starting point for tan, I start at the midline. The first asymptote is 2 dCVs away. Okay, from there, if you remember, the asymptotes or a period for tangent is the distance between asymptotes. So however far your period is, that's how spread out your asymptotes have to be. All right, and your period is pi, which we divided by 4 to get our dCV. So basically, a period is every 4 dCVs. So once you have your first asymptote, you can just draw an asymptote every 4 dCVs away. Okay, and so the first one is 2 away, and that's going to be the same every time. Then I'm going to go 1, 2, 3, 4. So the next one in the positive directions here at 3 pi over 2. Going negative from pi over 2 to the left 4 dCVs was this one at negative pi over 2. Then 4 more, 3, 4, I would be at negative 3 pi over 2. All right, and since your dCV is how we scaled the x-axis, and every 4 dCVs is a period, every 4 spaces away will be an asymptote. Okay, so again, starting point's the midline. First asymptote is 2 dCVs away, and then they're every 4. All right, so now I'm going to fill in these other 2 sections here. Between your asymptotes, there's always a midline point right in the middle, and then you should always have a total of 3 points or a total of 3 dots in each section, or between each pair of asymptotes, you should have exactly 3 points, excuse me. One on the midline, and then one that's A units up from the midline, one that's A units down. All right, and how you decide, like, to the right, do I go up or down? You need your shape, if it's positive, to look like this one. Remember, if it's negative, to be the opposite. Okay, so here's your positive, negative. And, okay, so if this one had a negative in front, the only difference would be each of these curves would be flipped. They'd be reflected. All right, so last thing, we're almost done. The asymptotes. I'm going to go back up here. Okay, so your generic formula for the asymptote, it's the first asymptote plus or minus the period times k. All right, so in this case, the first asymptote to the right is pi over 2. Plus or minus the period, which in this case we got pi times k. Okay, so basically your first asymptote is at pi over 2. You have another one every pi unit in both directions. All right, so that's it for this video, guys. I want to point out that this equation for asymptotes for number 1 is the same as your parent function. It won't always be that way. Okay, basically, once you start having different periods, then that will also affect where your first asymptote is, as well as how often the asymptotes occur. All right, so whenever the period is pi, this will be the equation for the asymptotes. But like when you get, for example, when we move on tomorrow to number 3, that will have a different period because pi over b is not 1. And your first asymptote will no longer be at pi over 2. All right, guys, so your homework today is to finish number 2. If you have any questions, please don't hesitate to reach out to me. You can email me, comment on Google Classroom, etc. All right, have a great day, guys.